तो ये इसी में फिक्स हो गया. Hello, good afternoon, students. Welcome back to Botany first year's class. So till now we have seen the SAQs from chapter 1, 2, 4, 6. So we will start with the other SAQs from the chapter 6. Okay. So we have started with the 6th chapter. We have seen this brief account of gametogenesis and the sexuality in organisms also we have finished. And the fertilization is not an obligatory event, and the juvenile phase and everything we have finished. And this question, they may ask, they may not ask, I cannot say, but we will go with the last question also from this chapter. Should not take any chance. Okay. So give a brief account on the phases of the life cycle of an angiospermic plant. When we are saying the angiospermic plant life cycles means haplontic and the diplontic based on the ploidy of the organism initially. That means the plant body initially may be the haploid or diploid in condition. Based on that, we can say the life cycle of an organism. So if the haploid plant body is there, it is continuing in the ploidy of the organism in the haploid manner only for a short period of time. That means during the sexual reproduction only, the diploid phase can be seen. Immediately after that, for that period only, that is the zygote formation. After that, again the haploid plant body has to be generated. So this is the, in this period of time is very less when we compare with the haploid phase in the life cycle of an organism. So in this case, we can call the life cycle as the haplontic life cycle, because we can ignore this phase, because which is a very short lifespan. After the formation of the zygote, immediately it undergoes the meiotic division to make the haploid plant body. So that is like this. We have to say the life cycle of an organism over here in this answer. Okay. This is, for example, I said how to prepare with these concepts. So the life cycle of an angiospermic plant, basically it is having the two phases, that is the sporophytic and the gametophytic. Sporophytic means already we have finished off this part. That is when the spores are produced from an organism, that is called as the sporophytic. Sporophytic, when the spores are produced from the organism, that type of life is called as the sporophytic life. And these spores are that are produced from the diploid plant body as well as from the haploid plant body, because this type of spores are going to be produced during the asexual type of reproduction. In the reproduction also, asexual reproduction, the spores are going to be produced by the plant body. So here the spores are produced, and these spores, mostly the haploid, sometimes diploid spores are going to be produced. Okay. And this is the dominant phase in the plant body. The sporophytic phase is the dominant phase in the any type of plant body. So this is the dominant phase of the life cycle. In this also, whenever the spores are produced by the asexual manner, then these spores will start producing the plant body directly. Okay, that is the during the asexual type of reproduction. When the spores are produced by the sexual type of reproduction, after the sexual type of reproduction, then they will also produce the plant body, and before that they will form the zygote. Okay, and some in the primitive and in the primitive organisms, and in some organisms these spores are produced from the zygote. From the zygote, spores can be produced. Example, funaria. What happens in funaria? In the funaria, after the sexual reproduction, the male gamete and the female gamete fuses, and a diploid zygote is going to be formed. And this diploid zygote undergoes meiotic division and forms the haploid spores in the spore sac. Like this, the funaria capsule. In this, the spore sac having the spores in them. These spores are formed after the zygote only, na? Zygote formation, that is after the sexual type of reproduction. So that is the most important one, because without these spores, the next haploid plant body cannot able to be produced over there. So this is the most important dominant phase only, na? That's what we are saying in the sporophytic phase. This phase is the dominant phase in the plant body, where the spores are produced from the diploid zygote by the meiotic division. Otherwise, from the asexual type of reproduction also, spores are going to be produced. So these spores, after they release into the suitable atmosphere, they will start developing into a new plant. That is the sporophytic phase. Now comes the gametophytic phase. What is meant by gametophytic phase? Gametophytic phase means where the gametes are formed. I said yesterday also. That is, the gametes are of the male gametes and the female gametes. That is, during the sexual reproduction only, this type of gamete formation can be seen, isn't it? During this stage only, we will see the male gametes and the female gametes. So obviously, this is the sexual type of reproduction. So whenever these two gametes are formed, that is called as the gametophytic phase. So this gametophytic phase is going to be seen in the organisms with when the zygote is going to be formed after this. Otherwise, from the diploid organisms as well as from the haploid organisms, male and the female gametes are going to be formed. This formation occurs by the meiotic, otherwise mitotic division. Okay, meiotic division when the organism is a diploid. When mitotic division when the organism is a haploid plant body. So like this, the division occurs and the male gametes and the female gametes are going to be formed. Whenever this has to be formed, they will be forming from the mother cells. Okay. Otherwise, we can call them as a diploid cell, sporogenous cell. Okay. So like this, the male gametes and the female gametes, and these two will be fused to form a diploid zygote. Always these gametes are haploid in number. So a diploid life cycle is going to be started after this formation and the fusion of the gametes, what we can say. So this is the haplontic life cycle, isn't it? Because completely the male gametes and the female gametes are the haploid in nature. So whenever they are haploid in nature, that life cycle is the haplontic life cycle. And after the fusion of these two gametes only, the diploid zygote is formed. From there, the diplontic life cycle is going to be started in the organisms. That's the one what here we are saying. In the gametophytic phase, what we have to say, it is the completely the haploid phase. Just now I said the gametophytic phase is the haploid phase where the male gametes and the female gametes are produced from the diploid spore mother cells. Okay, from the diploid mother cells, these male gametes and the female gametes are formed by the meiotic division, because they are asked in the angiospermic plant. In the angiospermic plant, these are going to be occurred in the flower, in the anthers and in the gynoecium part, in the ovary. So obviously there the cells are the always diploid in nature. So here the male gametes are produced from the microspore mother cell, and these microspore mother cells undergoes meiotic division and makes the microspores, otherwise the pollen grains. Or microspores. These are formed by the meiotic division. So in which cell the meiotic division occurs? Microspore mother cell, MMC, what we will say. This microspore mother cell undergoes meiotic division and forms the pollen grains, otherwise the microspores in the anther. Okay. And after this, the megaspores, that is the female gametes, are formed from the megaspore mother cells. That is also MMC, megaspore mother cell, which undergoes meiotic division and forms the one megaspore haploid called as egg cell. And this egg cell will fuses with the pollen grain, otherwise the microspores, and forms a diploid zygote. That is the end of the gametophytic phase. Okay, next one. We'll start the 8th chapter. Wait. Yeah. So with this question, the life cycle in the angiospermic plants, we have finished the 6th chapter. Now we will start with the 8th chapter, that is the taxonomy. So in the taxonomy, from this chapter, we will get one SAQ and one VSAQ. It's mandatory from this chapter, one SAQ, one VSAQ. That is of the 6 marks weightage is this chapter. Okay, and this chapter, in this one, we will be having the somewhat many questions, but in that we can divide it into 2 categories. One is especially with the taxonomic, and the another one will be the completely the family wise. So which question they will ask, we cannot say, but we have to prepare with all the sorts of the questions. So the first question is the based on the what is the question? Describe about the floral diagram. Floral diagram and the floral formula. That is the completely about the description of the plant body, the flower description. Okay, entirely the flower description we need to say in this. So here, whenever we are describing the flower according to the floral characters and how we have to represent it, that is the one what we have to answer in the first question. That is, here we have to describe about the floral diagram and the characteristic representation of all the floral parts in the flower. That is the calyx, corolla, androecium, gynoecium, and the ovary, and how many stamens are there, and how many locules will be there in the ovary. Everything we need to specifically represent with the representations. That is, with the symbols we need to represent this. So how to write the floral formula and how to describe about the complete floral characters of a flower, of a flowering plant. That is the one. So here we have to start with the description of the complete plant with the habit and the habitat. Okay. So whenever we are describing the habit, habitat, and the vegetative parts, habit and habitat, we can say the plant is a mesophyte and cosmopolitan in distribution. Okay. Otherwise, it is a where it is living. We can end up with that. Then the vegetative characters are the most important ones here. So these vegetative characters will be the root, stem, and the leaves. We have to describe about them. And after that, the floral characters need to be mentioned for the flower. Okay. First of all, vegetative characters we have to say, then the floral characters we have to say. Okay. So whenever the floral characters comes, in the floral characters, we have to describe about the how the inflorescence, then the flower, and in the flower, calyx, corolla, androecium, gynoecium, and how the pollination occurs, and which type of fruit is going to be formed in the plant body. Everything we need to represent in the complete characters of the organism of the flowering plant only. So here in the inflorescence of flower and its parts. And its parts means nothing but the calyx, corolla, androecium, gynoecium, everything. And after that, we have to describe how this floral formula need to be written for the plant itself. Okay. So in that floral formula, we'll describe only the floral characters of the plant body. Okay. The flower is having the bracts or not, and the bracteoles are present or not. Everything we will mention over there. Okay. So how to symbolize this? So in this, when we are saying that all the characters need to be mentioned in the representation of the floral characters, then here the how to represent these characters. So every time we cannot able to write the complete characters. So it needs to be symbolized with the shortcut form. That is the symbols. So here we have to go with the, first of all, the bracteate condition. When the bracts are present for the plant body, we can represent this with the BR. B should be the capital letter and R should be the small letter. Okay. BR means the flower is BR means bracts are present. If bracts are absent, then how to represent this condition? EBR. E bracteate. That is, bracts are absent. If bracteoles are present, then we will represent that with the BRL. If bracteoles are absent, then we will represent this with the EBRL. Okay. And next comes with the sexuality and the how to divide the flower. Flower can be divided into equally into two parts in any plane. Otherwise, the flower can be divided into only two parts in one single plane. That also we have to say, that is the merosity, what we'll say for the flower. So here, if the flower is the actinomorphic. Actinomorphic means when the flower can be divided into two equal parts in any plane, then that should be symbolized with the circle in the circle plus. That is the actinomorphic. If the flower is a zygomorphic, zygomorphic means when the flower is divided into two parts, in one single vertical plane. That is a zygomorphic. It should be symbolized with the percentage symbol. Okay. Next comes with the sexuality in the flower. Some flowers are the bisexual flowers and some flowers are only the unisexual flowers. What we have seen already. If the flower is only the male flower, then it has to be represented like this. If the flower is the female flower, then it needs to be represented like this. If the bisexual flower is there, that means both the sex organs are present in one single flower, then the flower is represented like this, bisexual nature. And once after this, what we have to say, how the calyx, corolla are present. Okay, calyx means sepals. Whenever the calyx need to be represented, it has to be written with the letter K, calyx K. Sound is coming as K, na? So it should be represented with the letter K. And corolla, C, capital letters. All these are the capital letters, no small case sensitive. And here below this, the number should be written for the calyx and the corolla. If those are the 5 sepals, then 5 number. And if those are fused, then that number should be kept in the brackets. Okay. If those are not fused, then it should be kept like that only without brackets. So the calyx should be represented with the letter K. Corolla should be represented with the letter C. And once the number of the calyx and the corolla, how to represent the number? If 5 sepals are fused, then it should be represented with the number in the brackets. Brackets represents the fused condition. Without a bracket, that's the free condition for the part. And if the calyx are 5 free, then it should be represented like this. If corolla petals are 5 fused, that is a gamopetalis. Okay. If the petals are free, then polypetalis. Okay. And in case if the petals are unequal in size, example Fabaceae family, where they are present in 1+2+2 condition. So corolla is 1+2+2 fused. 1 standard petal, 2 wing petals, 2 keel petals which are fused in condition. So it is the 1+2+2 fused. There is a Fabaceae family characteristic feature. In the entire plant kingdom, no family is having this feature. So this is the constant character, that is the specific character for the Fabaceae family. Next comes the sex organs, that is the androecium. Androecium should be represented with the letter A. And how many stamens are there? That number should be given at the bottom of this. If those are the 10, then we should write the 10. If those are present in the 5 in number, 5 stamens, then the 5. If that is fused, then like this brackets. If not, sometimes these androecium, these stamens are present in 2 bundles. In that 9 fused, 1 free. So 9+1 condition we have to write. Anything, the number is most important for the androecium. That is the how many stamens are there in the flower. Those are fused or free. And moreover, if the androecium, that is the stamens are fused with the petals at the base, that is, if this is a petal where stamens are fused at the base of the petal. That is the Solanaceae family, Datura. So, at this condition, how to represent this in the with the formula, in the floral formula, we have to write it as corolla 5, whatever may be the number, fused, and androecium 5 fused with the petals at the base. That is, it needs to be represented with the arrow that is attached to the androecium at the base. It is attached with the petals. That is the one with the arrow, we can say, from the androecium to the corolla. Okay. Next comes the gynoecium. Gynoecium is represented with the letter G, and below this letter we have to denote the how many locules are there in the ovary. How many locules are there, and all these locules are free or fused. Again, that needs to be said. Okay. And here, if the locules are 2, then you have to write the 2. And if those are fused, then put the bracket. And this ovary is above the thalamus or below the thalamus or inside the thalamus. And how to write this? That is the hypogynous, perigynous, and the epigynous flower. That is superior ovary, half inferior, and the inferior ovary. So whenever we are saying the superior ovary, that is placed above the thalamus, then the one small dash should be kept below the number of the gynoecium, otherwise below the G, so that we can say this as the hypogynous flower. That is, ovary is superior in nature. And why this type of representation? This is representing the base of the ovary, that is the thalamus tip. How the ovary is placed in the flower? Above the thalamus now. This is the base, what we are saying, representing here. Okay. On the thalamus, ovary is present. Gynoecium is ovary. So this is the base of the thalamus. This is the tip of the thalamus, what we can say. Like that, we can easily remember. Okay. This is the superior ovary above the thalamus. If the ovary is present as the half inferior or half superior, that is if the thalamus is having a small groove, in that groove, if this ovary is present like this, that means 1/4 part of the ovary is in the thalamus, 3/4 will be outside the thalamus, isn't it? So that is the half inferior or half superior. So that should be represented with a dash that kept in between the G. That is the half inferior or half superior ovary. Now comes if the ovary is completely inferior, then the thalamus is having a flask-shaped structure. Inside this thalamus, the ovary is present completely, and the style and the stigma will be above the thalamus. That is completely inferior ovary. So it should be represented with a dash that is present above the G, a horizontal small line. That is the inferior ovary, what we can say. Okay, these representations are very, very important for us. And next comes the floral diagram. Floral diagram represents the complete how the flower looks and how it is placed, where the bracts are present, and how the arrangement of the petals, sepals, and the androecium filaments and everything we can show. So with the floral diagram, we can give the complete information of a matured flower. Okay, matured flower, which is having the 4 parts in it. In the floral diagram, it is having the 4 parts. That is the calyx, corolla, androecium, and gynoecium. These are the 4 parts for the flower. Again, the 4 parts for the floral diagram. So, in this, the outer wall represents the calyx of the flower. That is the sepals of the flower. And from the outside, the second wall, second circle, will be representing the corolla of a flower. And the third wall represents the androecium. How many stamens will be there and how the filaments arrangement and everything. And the inner wall represents the gynoecium of the flower. Like that, in 4 walls, we can represent we can finish off the floral diagram. So the outer wall, inner, from the outside second, and the third, and the innermost wall. Okay, that is the calyx, corolla, androecium, and the gynoecium respectively, what we can say. And with this, and just below the floral diagram, whenever we are representing the bracts, we will say where the bracts are present for the flower and what is which phase is the anterior and the posterior phase for the flower when we are drawing in a book on a paper. Okay, that's the one why we are showing the bracts and the mother axis. So which part is attached, otherwise how it is faced towards the mother axis of the plant. That is the stem. Mother axis means the stem. That is the one what we are saying. Okay, so here we have to draw the floral diagram and the floral formula we need to write. And whenever we are doing this, if we learn the easiest one, then that will be the good one forever. Because in the Fabaceae family, if you take, here they have given the Brassicaceae family, but in the Brassicaceae family, only 4 sepals, 4 petals. Okay, and 6 anthers will be there. So 2 outside and 4 inside. So better to go with that it has to be drawn completely circle. If you cannot able to draw the circle, there is a problem. At any way, we can draw the oval shape very easily. So go with the family Fabaceae. That is the best method. So in this also, how to draw the floral diagram. Floral diagram start with the corolla, that is the second whorl from the outside, which is having a stranded petal. See how I am drawing. So it will be easy for you to draw in the records also, as well as for the examination point of view. These are the wing petals and these are the keel petals. We can draw this much oval shape now very easily. And after this, we have to draw the calyx, that is the sepals. So the sepals need to be drawn from the bottom. 1, 2, 3, 4, 5. Sepals are fused. Connect the sepals or petals with the arrow mark. That is nothing but they are fused. Okay, and it is having the lobe-like structure now. Easy. Now comes with the mother axis, this is the mother axis, and below this, it is having the bracts and the bracteoles. This is the bract, and these are the bracteoles. Now comes the stamens, number of stamens. How many stamens are there in the Fabaceae? Total 10, and in that 9 are fused. So start from here. This is 1, 2, 3, 4. Fifth one should be in the center. 1, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 stamens. Now the 10th one will be free. Like this, we need to draw the stamens. So in the last wall will be the ovary. Ovary is unilocular, like this. Okay. So with this, we have finished completely how to draw the floral diagram. What we said, same one. Outer wall represents the sepals, and the second wall represents the petals, and the third wall represents the number of stamens, that is the androecium, and the fourth wall, that is the inner wall, represents the gynoecium part. So everything we have done. And how to write the floral formula. So the floral formula can be written as bracteate, comma, bracteolate, comma, zygomorphic, comma, bisexual, comma, calyx 5 fused, comma, corolla 1 plus 2 plus 2 fused, comma, androecium 9 fused, 1 free, comma, gynoecium 1 thin carpus of inferior. Like that, we need to write the floral formula below this floral diagram, that is in a continuous at a stretch in one single line. It should not be broken to 2 lines, because here I could not able to get the sufficient space. So I have written in 2 lines, but you have to write in one single line the complete floral formula below the floral diagram. So if I'll write with this color, you can able to see bracteate, bracteolate, zygomorphic, bisexual, calyx 5 fused, comma, corolla 1 plus 2 plus 2 fused, comma, androecium 9 fused, 1 free, comma, gynoecium 1 fused, and half inferior. At a stretch it should be. It should not be broken down into 2 lines, because rules and regulations are there for writing the floral formula for a flower. So this is the way how to write. If you learn this, the third question will be coming, because in the third question, give an account of floral diagram. What now we have drawn and the floral formula, same thing if you explain over there, then the second question finish. So what is the floral diagram, how to draw the floral diagram, and what it consists? Floral diagram consists the completely the flower characters in it. That is, it is having the how the calyx, corolla, androecium, and gynoecium are present, and how many stamens are there, and the calyx and the corolla are fused, are free to one another, and the bracts are present or not, everything we will represent, including the mother axis of the flower. And here we will say how many stamens and how the ovary, that is this a superior or a half inferior or half superior, otherwise completely inferior ovary, like that, everything we can say. And the answers are monothecous or dithecous, intros or extros, everything we can show in the floral diagram. And after writing this part, we have to draw this diagram and give the floral formula. That's it. 4 out of 4 we will get. Okay. And now comes the non-essential floral parts of the Fabaceae family. Non-essential floral parts means the calyx and the corolla, because those are not important for the sexual reproduction, where they won't participate in doing the sexual reproduction, but they will make it easy by attracting the bees and the flies for the cross-pollination. That's it. But once the sexual reproduction will start, at that time, these two will fall off, wither off. Yesterday also we used the same word, wither off. So fall off. And at that time, which cannot be seen during the sexual reproduction, so we will call them as the non-essential floral parts. So the non-essential floral parts are calyx and corolla. Okay. So here, how the calyx and how the corolla, and this much if you have written and drawn the diagram, that's it. So here, calyx in the Fabaceae family, that also in the Fabaceae family. Now also we discussed about this family only now. Same thing, we are going with in the third question also. So in this sepals, calyx means sepals. Sepals are 5 in number and all are fused to one another. That is the gamosepalous condition. Gamosepalous condition and arranged in the imbricate aestivation. Okay, imbricate aestivation. And that is the odd sepal is in the anterior part. Odd sepal means the one what we have drawn during the floral diagram at the bottom. That is the odd sepal at the anterior part, because that part is faced towards the mother axis, because the bracts are present. Where the bracts are present for the flower? At this is the branch. This is the branch, the flower. Okay. Here the bracts are present. That means it is faced towards the mother axis. So that is the anterior part we are saying. The other part of the flower is the posterior part. Okay. So the odd sepal is at the anterior part. Just now we have drawn the floral diagram, with that we can say. Now comes the corolla. Corolla means petal arrangement in the flower. So how many petals are there in the Fabaceae? Petals are 5 in number, and those are present. All the petals are free. That is the polypetalous condition, and the arrangement is the papilionaceous. Arrangement is papilionaceous. Otherwise, the imbricate aestivation also we can say that is a papilionaceous only. And in this, how the arrangement will be present, otherwise the vexillary. We can take it as the vexillary aestivation. So in this, one big petal will be present, which is called as the standard petal, and that is also present on the posterior side of the flower, and the 2 lateral petals are present. Both are having the equal size, called as the wing petals, and the 2 small petals which are present as the keel petals, which are fused in condition. That is the completely papilionaceous corolla, otherwise the vexillary aestivation. In this 2 keel petals, what they will do? these two keel petals will enclose the stamens, otherwise cover the stamens and the pistil part, so that no other insect can come for the pollination process. So this is a mechanism where it will make the stamens to come out and the pistil to come out. That is the style and the stigmatic lobes. Okay. So this is and in this, how to draw this diagram? The corolla part for the Fabaceae family. So what we are saying, it is having the one standard big petal at the posterior part. Okay, and like this, the big petal will be present. Now comes the keel petal. Wing petals. Wing petals are the boat-shaped structures okay, which are meant to make the fly or insect to sit on it. And the next comes the keel petals. Keel petals are two in number, which are fused together, which will cover the stamens and the pistil part. Okay, so this is they will go with the pollination as the piston mechanism. With the piston mechanism. So how it works out? The insect, otherwise the fly, first of all comes and sits on the wing petals, so that these wing petals will be opened up broad. Then the standard petal will be opening the complete flower to the outside environment. Then the keel petals will be pushed up and they will be coming up along with the stamens and the pistil, so that the pollen grains can be collected and these pollen grains will be transferred to the insect body. So like that, whenever after that, once the insect, otherwise the bird flew off, then again the keel petals will go and the wing petals will come nearer to one another, and the standard petal will be closing the complete flower. Like this, they are protecting, that they are opening and closing it the pressure, that is called as the piston mechanism. Okay, like this, the completely the petal arrangement will be seen in the Fabaceae family. This is the non-essential floral parts, and the same thing we are having in the VSAQs. So the pollination occurs in the Fabaceae family by which process? That is the piston mechanism. The arrangement of petals in the Fabaceae family is called as the papilionaceous manner, otherwise the vexillary estivation. Okay, like this they will ask in the VSAQs also. Same 3 questions we can cover with 2 VSAQs. Okay, right? So we will wind up with this question, and we will see the other 3 questions, other 4 questions from this chapter in the next class, so that we can wind up this 8th chapter SAQs. Okay, right, students, thank you, and stay tuned to the same channel, same time for the next class, where we are going the most important VSAQs from the chapter 8.